Memory protection is about protecting you, the user, from the unintended consequences of problems in your programs. Today we'll explain how memory protection saves your whole system from coming down every time a program crashes. Welcome to Kopec Explains Software, the podcast where we make computing intelligible.
All right, Dave, before we dive into protected memory or memory protection, let's first just start with how is memory organized in an operating system?
And we're going to talk about this at a very high level. We have done 2 prior episodes that might be useful to people. One is what is an operating system? I'll put a link to that in the show notes. And we also did a prior episode on the memory hierarchy, which I'll also put a link to in the show notes. Anyway, at a very high level, the operating system is going to have 2 different kinds of memory. One kind of memory is for the operating system itself, the kernel, which is the center of the operating system, the device drivers, which are used for communicating with hardware peripherals, and then another layer of memory, and there's really more than just 2 layers, but I'm keeping this at a high level, for all of the userland programs. So these are programs that you use like your web browser, your word processor, your spreadsheet program. All of those are going to be in a separate area of memory from kind of the core of the operating system. The reason for that is we don't want any individual program to interfere with the core of the operating system. But it goes a little bit further than that. There also are individual slices of memory for each userland program. So Microsoft Word has a separate memory space than Google Chrome, and they can't invade one another's memory space. Having protections in place so that Google Chrome can't get into Microsoft Word's memory space is what memory protection is all about.
And why is that important?
It's important for 2 reasons. One is security, and the other is that we don't want the whole operating system to crash when one program has a problem. Let's take these one at a time. First, let's talk about security. If all of the programs on your computer were using the same memory space, then they could interfere with one another's operation. Now, somebody could do that accidentally, so one program could accidentally interfere with another program's operation, but that could also happen maliciously. If all programs are using the same memory space, then if one program had bad intentions, it could go and actually change the memory of another program. Memory protection prevents that. So that's really a very, very important reason that we have memory protection. But the other important reason is that sometimes it's not that somebody's being malicious, not that somebody made a bad program, but their program just has bugs. Maybe it has a large segment of memory that it's looking through, and it accidentally goes past the end of that large segment of memory. If there's no memory protection, it could accidentally go into the space of another program, because all memory at the physical level is actually one giant layer. But when we break it up in software, and sometimes there's also some hardware components that can help with breaking up memory into layers, and some actual CPU instructions that aid software memory protection. But anyway, if we really were able to just go off the end because we made a mistake, which happens, by the way, all the time. It's a very common programmer error to accidentally go off the end. But if we could go off the end and actually get into the memory of another program, we could accidentally change some of the values of the other program. And if we just corrupt our own memory, and then the operating system doesn't know how to deal with us, and the operating system is talking to us and it doesn't know what's going on with all these strange values we've put in the wrong places, that can also lead to all kinds of unintended consequences. So there's 2 different kinds of things we're protecting from. We're protecting from actual malicious software. That's a security component. And then there's the usability side of this. We're protecting from mistakes that programmers made, leading to the whole system coming down. So memory protection is about protecting programs so that we can actually ultimately protect the user.
So before there was memory protection, were computers just crashing all the time?
Pretty much, yeah. So if you go to, we'll just talk about personal computers today, but if you go to the early days of personal computers, so we're talking about the 70s through to the late 90s, most operating systems that consumers used did not have full memory protection. If you were using DOS or you were using Mac OS in the 1980s and one of your programs crashed, it would tend to bring down your entire system. You would actually have to go and physically sometimes restart your entire computer just because one program crashed. That was obviously not ideal. So it took a while, though, to actually get memory protection into consumer operating systems. Of course, the two dominant platforms in the consumer operating system space are Windows and Mac OS. And it wasn't really until Windows XP and Mac OS X, both of which came out around 2001, that most home computers had full memory protection. There was some partial protection in some earlier versions of Windows, but it wasn't full. And so it took a while. And so that was a real leap forward in usability for everyday users going from a non-memory protected operating system to a memory protected operating system. Because programs crash. Consumer programs crash all the time. I mean, even today, I'm sure everyone listening to this has experienced in the last couple months at least one program crashing at some point. Back then, happened to be a lot more software bugs. We could say that software engineering has gotten better. There's still tons of bugs, of course, but I think it's not as common for programs to crash as it was back then. But it was a double whammy because not only did the program crash, but then the entire operating system crashed. And Windows was notorious for the, quote, blue screen of death. Sometimes it was caused by Windows itself. Sometimes it was caused by programs running in Windows. But the fact that the programs could bring down all of Windows was because there was no memory protection.
So why didn't they include memory protection in the beginning?
Yeah, there's a few reasons for that. The first reason is it's just easier to implement an operating system without memory protection. So it's actually a little bit involved when you're implementing an operating system to really implement it with full memory protection. So it's simply these early operating systems, it was just easier not to. Another thing was that a lot of these early operating systems, like the original Mac OS and DOS, were single-tasking operating systems. So if you only had one program running at a time, you didn't worry as much about memory protection. Because if there's only one program and it crashes, that's like the whole computer's crashing anyway. So it was just not something that you considered as much because you didn't have two or more programs running at the same time. Then another thing is sometimes they would actually use the shared memory as a way of what's called inter-process communication. A way for one program to communicate with another program was actually done through using memory that both had access to. So if both have access to the same memory space, obviously there's not memory protection. But this was actually used as a convenience mechanism for programmers to get data from one program into another program while both programs were running at the same time. So there were a few different reasons, but ultimately it's just that these earlier operating systems were more primitive. They weren't as technically advanced. There is some small technical overhead that comes with implementing memory protection. There's a small performance hit that comes with implementing memory protection. And I mentioned earlier that there are hardware supports for software implementations of memory protection, and really early personal computing hardware, the CPUs didn't have those added supports. So for a multitude of reasons, these were just more primitive operating systems.
Is it important to measure how much protected memory you have as a user?
You don't need to worry about it in any modern operating system. Everything is automatically going to be protected. If you're running any current version of Mac OS, Windows, or Linux, all of them have protected memory by default. All of your programs are going to be protected. And you shouldn't actually worry about force quitting an application. So if you're on Windows and a program is not responding, and you then go Control-Alt-Delete, the task switcher comes up, and you go and manually force quit an application, you are going to take down all of the memory associated with that application, but it shouldn't affect at all the rest of the system. So back in the old days, when you would do something like that on Windows before Windows XP, you actually had to worry that when you did that, you might actually lead to some corruption of the memory around it. Maybe it didn't really, just take down itself. Now you shouldn't worry about it at all. You just do Control-Alt-Delete. If some program has a problem and you need to end it, it shouldn't affect any of the other running programs. The same is true on Mac OS as well. On Mac OS, the key combination is Command-Alt-Escape. If you do that and you have a program that's having a problem and then you click it and you force quit it, it should not affect the rest of the system. So it used to be that after people did that on the old Mac OS or the old Windows back in the 90s, the advice would be that after you do that, go and restart the system so that all the memory is fresh, because maybe that program that was having trouble got into the memory space of the rest of the operating system or other programs. Today, you shouldn't just worry about it. If you have trouble with the program, just force quit it. I think the last thing we should mention is that memory protection really came hand in hand with more advanced multitasking. We could do a whole episode, which we probably will in the future, on multitasking. But once operating systems really had to handle, and we're mainly talking about personal computing operating systems today, really had to handle multiple programs running at the same time, that's when operating system makers got more and more concerned about memory protection. There were consumer operating systems going all the way back to the 1980s that had memory protection. They just weren't really popular, like Mac OS or Windows. But once we started to be running multiple programs at the same time, that's when we really worried about protecting each of their own memory space. And that's when memory protection really became a major feature on the wish list of technical users and also for operating system manufacturers. Okay, thanks for listening to us this week. Rebecca, how can people get in touch with us on Twitter?
We're at Kopec Explains, KOPECEXPLAINS.
Thanks for listening, and we'll see you next week.
Bye.